Okay, so we've looked at the concept of reliability in terms of the relationship between the observed test score and the true test score. And we've seen one way of measuring reliability by splitting tests in halves and looking to see how the halves relate to each other. Because we can only observe, we don't know the true test score. Another class of reliability measures looks at, within a test, it's another internal measure, like split halves, except that here we look at the correlation of each test item, the scores on each test item, as how they compare to the scores on all the other test items in the test. The two methods for this are raw alpha or Cronbach's alpha and Kuder Richardson, and we'll talk about those just here in a minute. The raw coefficient alpha looks at each item level and compares it to test level statistics. So we look at the variance of the scores on the test in total, and then we look at the covariance between each pair of items. We sum the covariances and divide by the variance and multiply by the number of test items divided by the number of test items minus 1. And then we sum those up. So basically, I'm not going to do that by hand for you. We can do it easily and simply in SPSS. So if you'll take the file called SPSS reliability, open it up, and what we have here are our test items. Remember our 10 people who took that test and their scores on it. This is an SPSS data set, and if we go analyze, scale, reliability analysis, we can put each of those 8 items into our reliability analysis. We can look at the statistics we want. We can do correlations and covariances if you like. We could do means and variances if you wanted. But why not? Okay. And this is the raw alpha coefficient, so we'll do that first. You could do split half, and in fact, yeah, let's do split half first because we've already done it. Okay, so basically it's the third method, the third split half method that we've got. They look at the first 4 items and the second 4 items, and here you can see the correlation that we got back on our spreadsheet of 0.713. Remember right here? In fact, you want to do one more. Oops. 713. And our Spearman reliability coefficient of 0.833. And if you just looked at these two split halves, you would conclude that this test is reliable because those two halves highly correlate to one another. Okay, so we've done split halves. Here's our item correlation matrix, inter-item correlation, and here's our summary statistics. And you could compare those to the spreadsheet if you like. So here's correlation, covariance. How about if we wanted to do a Cronbach's alpha? So again, we're going to do analyze. Did you see how fast and easy this was? Scale, reliability analysis, except this time we're going to do alpha. Do OK. So Cronbach's alpha with 8 items is 0.5. So 50-50 is really what we're saying. And that's relatively good. It's not great. It's relatively good. This, as you see, provides a much more sensitive measure than the split halves because it looks at each item in the test compared to every other item on the test. So basically, an item-by-item analysis, and that's the essence of Cronbach's raw alpha, and that's SPSS applying this formula across all of them. Okay, so what about tests where the results are true, false, or correct or incorrect? A multiple choice test. Well, now we don't have values or scores. We're going to be right or wrong. We're going to be in a 0 or 1 world. And so the approach to that is we use a Kuder Richardson 20 formula. And here is that formula at its simplest. The item variance is the probability of correct, or the proportion correct, times the proportion incorrect for each question. The variance of the total scores is the sum of the responses to the items. Here, I did a Kuder Richardson 20, 10-item test. 10 people took a test with 6 items, and here are their right or wrong scores. So you sum up the scores for each person, sum up the scores for the item, find the mean for the item. The variance is the mean times 1 minus the mean. So that's PQ, or the variance, for each of these items. We also get a mean and a variance for each of the people, and develop a variance. So K was 10, that's the number of people we had. K minus 1 is 9. That divided by that is 1.11. So we have our variance for the people. We have the sum of the PQs, the variances, divided by the variance is 1.38. And we subtract that from 1 to get a Kuder Richardson score of 0.42. So it's actually the same concept here as Cronbach and on Spearman. So let's take a look. We can do the same thing in SPSS. SPSS reliability 2. And here are our test scores entered into our matrix, and we analyze it exactly the same way. Reliability analysis, and we'll do an alpha. We'll put our items in, and SPSS will just automatically do a Kuder Richardson when we're looking for alpha. And so here we are. Cronbach's alpha for these, which is Kuder Richardson alpha, is 0.271, and that's pretty low. So basically the reliability of our right-wrong multiple choice test is not very high. As you can see, doing these in SPSS is pretty easy. Again, I don't care if you want to do the math, fine, but you don't need to be able to do the Excel spreadsheets. You don't even need to be able to do this in SPSS, although it's really easy enough. If you're using an instrument or a test, you can analyze the reliability of that test using Cronbach's alpha or Spearman-Brown or Kuder Richardson. I think it's really simple enough. You ought to be able to do that pretty easily if you're designing tests. I hope this helps. Let me know if you have any further problems.